Hello, welcome back. I introduced myself in the last lesson. Well, you can definitely uh, rely on what I teach you because I've taught the same thing for about 50 years. And hopefully, I have been teaching it right because I got every year I used to get the number of A's and B's and A stars. So hopefully, I think I'm doing something right. Sorry, I'm just joking. My name is Sosale Mohana. I'm a teacher of high-level maths. I've taught for about 50 years and I'm just using these lessons to go over the content of pure maths which you have learned in school to help you refresh your memory and prepare for your exam. So in the last lesson, we have finished all the various standard methods of integration at A level which you're supposed to know. And I'm not taking examples that involve all the methods at random. Even though I didn't do it at random, I use these two now, it will be at random. So that the second lesson, remember I said I will complete the alphabet. I had done A to G, so I'm starting with H. Integral 10 power x dx. You cannot quote a formula because it's not a standard formula as usual. I forgot to turn on the stopwatch. There. Taken about a minute, so it's fine. So, remember, a power x equals e power x ln a. So, 10 power x equals e power x ln 10. I prefer doing it this way. I'll show you another method as well. So, it's integral e power x times ln 10 dx. Now, this resembles e power x, but it's actually x times ln 10. When you differentiate x times ln 10, you get ln 10 not 1 over 10. ln 10 is a constant. So, when you differentiate ln 10 times x, you get ln 10, which is a constant. So, you can apply the formula directly. E power x gives you e power x. And then, the constant I got on differentiation was ln 10, so I divide by ln 10. So, it is 1 over ln 10, 10 power x plus c. Suppose you don't remember that. No problem. I will show you substitution. U equal to 10 power x. Again, I don't know how to differentiate this. Remember, sir, agreed, but I don't, no problem. Get rid of the power. So, can you say x ln 10 equal to ln u? Find dx by du. Dx by du equals, dx by du times ln 10 equal to 1 over u. Yeah. So, therefore, dx equal to u, ln 10 times du over u. Put it in the integral. 10 power x is u, dx is u ln 10. Dx is du over u ln 10. U and u cancels. Remove 1 over ln 10 as a common factor. I get 1 du, which is u over ln 10, which is 10 power x over ln 10 plus c. Same answer. Either you can do it the way I showed you, or you can do it this way. Very good. I've got series of questions written down there. By the time I write from there to here, I change it. Okay. Next, integral. I have done h. Now I am on I. Integral cos squared 4t dt. You cannot integrate cos squared directly. You cannot integrate sin squared directly. Anyway, the logic. Can't integrate directly. If I differentiate a cos, I get a sin. I don't have a sin, so I can't use substitution. It's not a fraction, so I can't use partial fractions in the rules. But it's a trig function. See, I had taught you, I had gone over rather, your teachers have taught you, I should say, and I have also taught you, sorry, during the lessons, how to integrate an odd power for cos and an even power of cos and sin. Whenever it is an even power, use double angles. I have a cos squared, so I'll write the formula of cos 2a in terms of cos. So cos squared a equal to 1 plus cos 2a over 2. So cos squared 4t is 1 plus cos 8t and a half, which is half of t plus 1/8 sin 8t plus c. That is a standard way of integrating a cos squared and a sin squared. Very good. So I have done I. At least I know the alphabet, if not anything else. So let's look at J. J is integral sec power 4 2x dx. Can't integrate directly, can't use substitution. It's not a fraction, even though I can write as 1 over, but that doesn't help. So the only way I can do is trig functions. Remember, tans, any power of tan, even powers of sec and cosec, split them into power 2 and another power. So I'll write this as integral sec squared 4x times sec squared 4x dx. Right? For tan and cot and cosec and sec, split as even power. You got 2. Convert only one of the even power. In other words, sec squared. Whatever sec squared you got, keep it as it is, and something else you convert it, if where needed, into tan. So the first sec squared 4x, I keep it as it is. This sec squared I'll write as 1 plus tan squared 4x. When you differentiate a tan, you get a sec squared. Yeah? Of course, what do you get when you differentiate tan 4x? I get 4 sec squared 4x. So if I'm using inspection, quarter integral 1 plus tan squared 4x times 4 sec squared 4x dx. This is 1 plus u squared du. So when you integrate, I'm using inspection, 1 plus u squared du. 1 du gives you u. It's 1 plus u squared du, where u is tan 4x. Difficult to think, right? So let's not do it that way. I mean, I can do it, but you will get confused. So the better thing will be to use u equal to tan 4x, du by dx equal to sec squared 4x. So dx equal to du over sec squared 4x. Common student error. I forgot the 4. I forgot the 4. So it is quarter integral 1 plus u squared du, which is quarter u plus u cube over 3, which is quarter times 3u plus u cube whole over 3. So 1 over 12 u times 3 plus u squared. So the answer is 1 over 12 tan 4x times 3 plus tan squared 4x plus c. Right. That's how you integrate sec squared and sec squared, or sec power 4. Okay. As we go further, the questions are going to become longer, as you will see. There are 4 questions which I am going to take. J, I have done J. I have to do K now. K is integral 1 over 9 minus x squared dx. Can I integrate directly? I can't. It doesn't resemble 1 over x because there's an x squared. Can I use substitution? I can't. Because when I differentiate 9 minus x squared, I get minus 2x. There is no x in the question. Then it's a fraction. What's the fundamental rule for a fraction? The highest power in the numerator must be smaller than the highest power in the denominator. That's power 0, that's power 2, so it's a proper fraction. Differentiate the denominator, I get minus 2x. Do you have an x in the numerator? No. So I can't use f dash of x over f of x. Then what choice do I have? Can I factorize the denominator? Partial fractions. If I can't factorize the denominator, complete squares, use inverse trig. That is the logic for fractions. It's interesting. Let me go for a fraction. First thing you do is check if the power of the numerator is smaller than the power of the denominator. I mean highest power. Yes, proper fraction. No, divide and then use only the remainder or denominator to deal with next bit. Okay. Next, differentiate the denominator. I did. Do you have the variable of that? For example, here it was 9 minus x squared. When I differentiated, I got 2x. The variable is x. Do you have an x in the numerator? No. So I can't use f dash of x over f of x. Then can you factorize the denominator? Yes. But if I could not factorize the denominator, then I have to complete squares where necessary and use inverse trig integration, which I did a couple of lessons ago. But I can factorize the denominator, so it is 1 over 9 minus x squared dx equal x squared equal to something over 3 minus x plus something over 3 plus x. Yeah, because 9 minus x squared is 3 minus x times 3 plus x. This is a constant A, that's a constant B. You also know that you don't take LCM, multiply everything by the denominator of the question. So I get identity 1 is equal to A times 3 plus x plus B times 3 minus x. Put x equal to 3, A is 1/6. Put x equal to minus 3, B is 1/6. So it is 1/6, 3 minus x, 1/6, 3 plus x. Keep that in mind because I don't want to kneel down to write the remaining steps. I will put it there. So that becomes, I can remove, that's equal to integral 1/6 over 3 minus x plus 1/6 over 3 plus x dx. If I remove 1/6 out, I get 1 over 3 minus x dx plus 1/6 integral 1 over 3 plus x dx. Why did I write like this? Because I want to go over integrating fractions. Now, the moment you have done partial fractions, the rule is normal and you should be able to integrate directly. What do you get when you differentiate 3 minus x? I get a minus 1. What do I have in the numerator? 1. So can I make it a minus and a minus? Here, the numerator is the exact derivative of the denominator. Integral f dash of x over f of x is ln f of x. So it is minus 1/6 ln 3 minus x plus 1/6 ln, using the same logic, 3 plus x. So it is 1/6 ln 3 plus x over 3 minus x plus. Very good. It's very thirsty. Pretty warm. As I keep talking, my throat goes dry. Alright, I have done K. Let me do L. Interesting, as I will show you, x over 9 minus x squared. Can I integrate directly? No. Suddenly, sir, look, we did 9 minus x squared in the previous case, so why don't we just do the same thing? Use the partial fractions. God gives us brains, yeah? Use it. Look, but what the first rule? Is it a proper fraction? Yes. Once it is a proper fraction, look at the derivative of the denominator. What is it when you differentiate 9 minus x squared? What is it you get? Minus 2x. What do I have there? X. So what's missing? Minus 2. So whenever a constant is missing, you can always multiply and divide by the constant. So can I write it as minus half integral minus 2x over 9 minus x squared dx? Now, the numerator is the exact derivative of the denominator. So the answer is ln denominator. A simple x changes the whole complexion. So I've done L. Now I'm doing M. Let me cancel the M as well. M. Integral x squared over 9 minus x squared dx. Aha! Can't integrate directly. I can't use substitution because when I differentiate 9 minus x squared, I get minus 2x. I've got an x squared. It's a fraction. Rational expression rather, algebraic fraction. The highest power in the numerator is 2. The highest power in the denominator is also 2. If the powers are the same or if the numerator is higher, you divide. So I divide x squared by minus x squared plus 9. I must multiply by minus 1. So I get x squared minus 9. Subtract, I get 9. So it's integral minus 1 plus 9 over 9 minus x squared dx. I can integrate, that's minus x plus 9 integral. I have 1 over 9 minus x squared. You now use partial fractions and go through the whole thing. I get 1/6 over 3 minus x plus 1/6 over 3 plus x dx. I don't want to go through partial fractions. I did it about 2 questions ago. So it's minus x plus 9 over 6 times minus ln 3 minus x plus ln 3 plus x. Or it is x plus 3 over 2 ln 3 plus x over 3 minus x plus c. Yeah? Look, constant x squared. So you can guess now what will be the next one. Yes, yeah, you're right. X cube. I've done x squared. Let me do x cube. Alright. I've done m. I'm now going to do n. X cube. Straight away, I don't. I stopped myself there, didn't I? Why? Because I realized that if I were to call u as 9 minus x squared, du by dx would be minus 2x. The numerator is x cube, which I can write as x cube, x squared times x. I have a function and its derivative, aren't I? I can use substitution even though it doesn't look like one. So therefore, dx equal to du over minus 2x. So it becomes integral x cube over u du over minus 2x. So it is minus half integral x squared over u du. I cannot integrate this because I have an x squared, but x squared is 9 minus u. So it is minus half integral 9 minus u over u du. That is minus half integral 9 over u minus integral or du minus 1 du. So it is 9 over 2 minus 9 over 2 ln u plus half u. So it is minus 9 over 2 ln 9 minus x squared plus half of 9 minus x squared plus c. Of course, in the exam, or if this is in a textbook, this is the answer you will see. You will see minus 9 over 2 ln 9 minus x squared minus half x squared plus c. What happened to that 9 over 2? See, if I open the brackets, I get a 9 over 2 minus half x squared. So I have the minus half x squared. That 9 over 2 has gone somewhere. This is a trick, but it's common sense. Look, c is a constant. 9 over 2 is a constant. 9 over 2 plus c is another constant c. So any constant in your answer, you can absorb it with the c. But if you leave it there, there is nothing wrong. See, just one power increase makes each solution completely different from the previous one, isn't it? That's the beauty. So I'll stop there. We will continue with O in the next lesson. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.